Well, thanks for being willing to do this, Ammon. Do you
My
want to just
pleasure.
first kind of, I guess, introduce yourself? Tell us a little bit about your education, your background, where you're from, what you like to do, that kind of thing.
Sure. Yeah, so I'm Ammon Hepworth. I worked with Brett, Dr. Stone, or Brother Stan, I guess they call him at BYU, Idaho.
Yeah,
So I have
any
a
of those work.
PhD as well. And I so I did my bachelor's and master's at BYU. Then I left for a while, went to ExxonMobil, went to Pratt and Whitney, and then went back to BYU for a PhD. So worked on multi-user CAD development, different aspects of that, people side as well as the algorithm development and the client-server interactions with that. Then after I finished, I worked for Siemens that makes NX. I worked on some of the advanced simulation technology there as a software developer, but got pulled away to work with Greg Jensen, who was my advisor at BYU and one of Brett's graduate advisors as well.
Hmm.
And so he and I worked to try to start a company with the multi-user CAD to develop a plugin for NX to make it multi-user. But a series of kind of difficult challenges made it so it didn't happen. We had part of our group was on the business side was a bit dishonest. We started a lawsuit with them, and then the second group we got involved with, the guy ended up in prison. So it was a little bit rough going, but
Yeah,
definitely a good learning experience. And but I needed a real job, and so I ended up coming back to Pratt and Whitney and enjoying that for the last year or so.
that's great. So let me ask a little bit more about some of the jobs that you've had, like with ExxonMobil. Tell us kind of what you were doing there.
Yeah, so I guess I'm kind of a serial job hopper. I'm trying to stop, but it's been a good career so far. So actually, before Exxon, I had already previously worked at Pratt as an intern,
Okay.
which is why I've kind of returned a bunch of times. But before that, I worked as a designer, draftsman when I was in school.
Hmm.
Just for a company that designed they were doing a winged redesign on the A10 Warthog,
Oh, cool.
and I was working on NX doing the design, which is how I got the internship with Pratt.
Hmm.
And then also while I was at school, I did a summer at Skunk Works, which is Lockheed Martin's secret aerospace center in the middle of the desert in California.
Yeah.
That was a fun summer to spend there as well.
How much
But
can you tell us about
Exxon
what you
was my
worked on
first
there, or
job.
would you have to kill us?
What's that? That's right. I can't. I couldn't tell you.
Okay.
But yeah, Exxon was my first full time job out of school, and I'd already got some exposure to some fairly creative jobs, and so I only stayed at Exxon for a year just because for me it was a little too cut and dry. I was analyzing oil fields. It was interesting enough. I was working on analyzing an oil field in Iraq, actually,
Oh,
and
really?
trying to figure out how much we could produce a year and where to drill wells and looking at the geology of the earth and figuring out how much oil was down there based on some core samples and
Hmm.
interpolation of the different core samples to try to figure out what it looked like down there.
Mm.
But for me, it was a little just I just used the software, run the simulations, and I found it a little bit dry. So I had remembered I liked Pratt and Whitney from my internship before, so I ended up going back there with the same group I was at.
Hmm.
And I really enjoyed that because there's a lot more creativity involved working on jet engines at Pratt and Whitney. It's a little more cool.
Hmm.
One of the mechanical engineers' kind of dream,
Yeah.
right, to work on something like that, planes or cars or cool machines like that. So
So at
I
Pratt, were
enjoyed that a
you
lot.
at Pratt were you working on like turbines, or were you working on cases, or what was your?
So they kind of divide the engine into two main areas: the cold section and the hot section.
Okay.
The cold section being like less than 1,000 degrees, basically.
Cold.
That's cold. Yeah,
Right.
exactly. I was cold section and mostly working on fan and compressor, the front side of the engine.
Gotcha.
And there's lots and lots of parts, like 100,000 plus parts in a jet engine. So there's a lot of design of those. And so I worked on
it's a big
building,
assembly.
Actually a parametric model of the entire compressor. And so you could swap in different geometries for the different blades, and we could resize the core so it would get larger or smaller based on some different inputs. So it's cool. A big parametric modeling study that they ended up using for a few years. Actually, someone at Pratt & Whitney still has what they call a rubber engine, and that's it's an engine model that they use mostly to do some preliminary design on, to try to size it and then figure out what the weights would be and some early analyses to try to figure out some things before they do the more detailed design.
Awesome. So what do these engines go on? Like what kinds of planes did the engines that you worked on eventually go into?
So Pratt & Whitney does both commercial and military. So the military engines are F-35 and the F-22.
Very cool.
And then the commercial, the big technology that Pratt & Whitney is developing now is called geared turbofan. It's a technology they developed that makes the engines like 3 orders of magnitude more quiet and about 15% more fuel efficient. Traditionally, jet engines, the whole engine turns together with one tie shaft, and so the compressor and the turbine are all moving together. But this technology allows the fan and compressor to move slower than the turbine, which makes it more efficient.
Yeah.
And that it sounds like a very simple concept, but no one's was able to develop the gearbox to do it. And Pratt figured out a way to do that, and is selling a lot of those engines now.
Yeah, I bet. So I guess kind of moving on to our next question, what's some of the best advice that you've ever received as you've been going through all of this schooling and these different jobs and opportunities that you've had? What's the best advice you've gotten or that you could offer to engineering students in their undergrad?
So I think I remember something my dad told me when I was starting my career or somewhere in the middle of it in school. He was like, so when I go to work, I ended up just staying 15 minutes longer than everybody else. So instead of leaving right at 5 o'clock, he stayed just a few minutes longer. And he said that made a huge difference, just staying just a little bit longer, just to stand out a little bit. And I don't think, what I realize is that you don't necessarily need to stay longer, but if you can work just a little bit harder than the rest of everybody else, it'll show, and it makes a difference. And I think the lesson that I learned there was put your heart into your work. Do quality work, and it'll show.
Yeah.
And if you have, I think what advice I could give is if you're passionate about what you do, it also shows. And don't be afraid that you can't do something, because you can figure it out. And I think if you have that attitude that, okay, you may not know how to do it now, or you may not understand everything, you can learn it. You're smart people, and you can figure it out.
So you're saying that despite all these cool things you've worked on, there were times that you didn't know what you were doing? Is that what you're saying?
Yeah, of course. Yeah, there were times where I was like pretty clueless, or sitting there in a meeting and not understanding anything anybody was talking about. And it takes time sometimes, or other times it's just like asking questions. Just ask everyone you know, because some of that's you can't find on the internet. You're gonna have to just talk to people. And other times it's like there's knowledge that you need to figure out this new area, and you just got to read everything you can about it. Just tackle those challenges. But yeah, a lot of times I still feel like I don't know a lot. There's all these different areas that I want to know about that I'm just trying to read up and learn about so I can know what I'm talking about.
No, that's great. Okay, so next question. What does it mean to you to be an engineer of faith?
I think uh, I think it has a lot to do with no matter what you do, you always remember that God is there and that He's watching what you do, and you need to make sure that you behave in an ethical way.
Oh.
I think at work, sometimes, especially as an engineer, you're making decisions that affect people's lives. One of the reasons the Challenger blew up is because people didn't speak up.
Mm-hmm.
They knew something was wrong, and there was a high risk, and yet the managers didn't put their feet down and say, no, we shouldn't do this. They went ahead with it. And I think if you know something's not right, or you suspect that something's not right, say something about it. Mm-hmm. And I think that's very important as an engineer, as an ethical engineer, and as a person of faith.
Great. Thank you. So have you ever, you talked about the Challenger, but for you personally, have you ever encountered any sort of challenge to living the gospel be in your engineering work specifically? And, if so, how did you kind of overcome that, or how did you deal with it?
Yeah, I think I realized early on that not everyone was going to be ethical. Sometimes things slide, or you don't. If you don't say something, people will end up just going with maybe a uninformed decision. Mm-hmm. And I think what I developed early on was that I had to be aware all the time and be ready to say something. Because I think when I was younger, I was like, oh, everyone else knows better, and I shouldn't open my mouth. But just little things that would come up that people would say, oh, well, okay, so something even just recently that came up in the last 6 months or so, they were making a presentation to the executives, and it's a chart that shows this is complete, and moving along. But they were claiming that part of it was complete, and yet it really was only half complete. Mm-hmm. And so I was saying, well, no, we need to make sure that everybody knows that it's not fully there, or we finish it before you give the presentation.
Right.
I think what we ended up doing is saying we're in the middle of working on it and making progress, but not fully complete on this part of it.
Right.
And so in that way, I think it just more clearly explained the message and not confused where we were. And that's really important, because being unethical or dishonest can cause more problems
than it solves.
Than it solves, exactly. Yeah. Plus, you need to be the person that God expects you to be.
Right. Awesome. Well, do you have anything else you want to tell the students, or anything else that you think you'd like to mention?
So I think the big thing is I highly recommend every student getting an internship. Please go out and do that. You're going to it will really pay off when it's time to go get a job.
Yeah.
And make sacrifices to do that. The other thing is, when you're looking for a job or internship, quantity is a big thing. Try to get as many resumes out as possible. Talk to as many people, friends, family, mm-hmm. Parents, people you know, and just get your resume in as many hands as possible, and that makes a difference.
Awesome. Well, hey, thanks so much, Ammon. I really appreciate your time.
Yep, no problem. It's been a pleasure.
Yep, thank you.